All right, guys. So we're starting chapter 4, the next chapter. Most of y'all did pretty well on the test. There are certain parts that y'all missed. And for different reasons, this here and there. I have a feeling a lot of it, when looking back at it, I think some of y'all did fill in the note sheets, or especially the review sheet. And I know there's a good number of you that fill it in as I go over it with y'all, which really does you guys no good, to be perfectly honest with you. Because the review sheet is for y'all to look back on the test to get help for what you're missing. If you don't do it in the first place and just follow along, it doesn't give you any basis to actually refer back to, because you have no real connections or memories with it. It's just a bunch of numbers written on a page. So again, taking the time to do the review sheet and getting those is going to help. Also, again, as a reminder, you can do makeup points on any of the tests. So once everybody's finished, there's still a few that haven't finished the test. Once everybody's finished with the test, you can come back and fix the ones you got wrong for half credit back. Okay? Now, looking at chapter 4, we're talking about polynomial functions. Now, quadratics are a polynomial function. They're just a polynomial function of degree 2. So you don't have to write this down, but this here is considered a polynomial function, because all of our polynomial functions are going to have variables and exponents of some kind. Polynomial functions, recall that a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. A polynomial is a monomial of sum, so a sum of monomials of these terms. And this here is the general form of any polynomial function, where a sub n minus 1, a sub 1, a sub 0 are just numbers. They're just coefficients. There are numbers. There's no variables attached to it. X to the n. So we could say that this is x to the 6th. So x to the n minus 1, so x to the 6th minus 1 would be x to the 5th. X to the 4th decreasing. And this is just to write it in a general form. Now we do have here, we provided, and we can see some examples of different polynomial functions. So if the degree is 0, it's going to be a constant function. F of x equals a to 0, or f of x equals negative 14. A constant function is just a number. A linear function has degree 1. The biggest exponent is 1. So we could say 5x minus 7. If the degree is 2, it's a quadratic. Our ax squared plus bx plus c, or 2x squared plus x minus 9, is a quadratic, because the biggest exponent is 2, the degree is 2. Cubic is a degree 3, because the biggest exponent is a 3. So x cubed minus x squared plus 3x. And a quartic is degree 4, because the biggest exponent is a 4. Questions on any of this so far? Now, standard form. What we consider standard form is writing the polynomial in order of decreasing degree from highest to lowest power, going from left to right. So the biggest exponent, the variable with the biggest exponent will go first, then next going down the line. And when we talk about the leading coefficient, we're talking about the number in front of the variable with the biggest exponent. Leading coefficient is going to be the number in front of the variable with the biggest exponent. Questions on this so far? Now, what do we define as a polynomial? Well, with this here, it's sometimes hard to define exactly what something is. It's easier to define what it is not. So the first thing we can say is that the exponents aren't negative. If it's a polynomial function, the exponents are not negative. We cannot have a negative exponent. So an example of that would be x to the negative 2. We cannot have a negative exponent. That would not be considered a polynomial function. That would actually classify it as a rational function. The next one. Exponents aren't fractions. We can't have x to the 1/2. We can't have variables inside a radical. So square root, cubed root, any of those, we cannot have a variable inside of a radical. So we can't have the square root of x or the 9th root of x. We cannot have a variable inside of a radical. We can't have variables multiplied together. X, y, x times y, just an example. Questions on any of this so far? This cannot be in the bottom of a fraction. Three, four, five, and we do need to add one more. Let's see here. Tags. I spelled exponent wrong. Sure. Variables can't be in an exponent. Yep. I just need to switch back to normal n, because all I was missing was an n. So the only other one that we can have is variables can't be an exponent in an exponent. So like 3 to the x. This is an exponential function. They increase faster as they go up. Because 3 to the first power is 3, 3 squared is 9, 3 cubed is 27. They're increasing faster and faster. So those are considered exponential growth or decay. Questions on this so far? So we kind of get this here, yes? And really what we've done with this here is eliminated everything that's not a polynomial function. So if we look at A, first we want to decide whether it's a polynomial function, and if it is, we want to write it in standard form, state its degree, type, and leading coefficient. So if we look at this first one, A, negative 2x cubed plus 5x plus 8. So first thing, do we have any negative exponents? No. Do we have any fractional exponents? Any variables inside of a radical? No. Any variables being multiplied together? No. Variables in the bottom of a fraction? Variables in an exponent? So can we say this is a polynomial function? Yes. So this is a polynomial function. Now, we want to write it in standard form. So we want the biggest exponent first. Is it first? Because which x to what power is the biggest? X to the, is it the one that goes first? So the next biggest power is 5x, because to the first, so it would go second, and 8 is third. So is this in standard form? Yeah, so it's already in standard form. Now, the next thing it asked for was degree. The degree of these polynomial functions is the biggest exponent. So what is the degree? 3. Type. So it was on that first chart. What did we call a degree 3? Look back at it. Cubic. A degree 3 is a cubic. Leading coefficient is what? What would be the leading coefficient? It is the number in front of the variable with the biggest exponent, so that would be -2. Let's look at B. Can we say that B is a polynomial function? So why would we not? So they're out of order, but do we have negative exponents? No. Do we have fractional exponents? Do we have a variable inside of a radical? Is the square root applied to just the 2, or is it applied to both the 2 and x to the 4th? Just the 2, yes? Because if it was applied to both would be inside of it. It would extend out. So here, it does not. It's applied just to the 2, yes? Because if you want to write these to make sure, because we can always put the little bar down to signify that it doesn't include it. So, okay, so the variable is not in the radical. Do we have variables multiplied together? 2 different ones? No. Variables in the bottom of a fraction. Variables in an exponent. So is this a polynomial function? Is it in standard form? No. So to put it in standard form, we need the square root of 2, x to the 4th to go first. And since it's positive, we don't have to write a sign in front of it, because this is the biggest variable with the biggest exponent. Question? What? Huh? What's the next one? Minus 0.8 x to the 3rd, because the next power we would want is the 3rd power. Since we started with the 4th, the next one would be x to the 3rd. After that, we would have x squared, but we don't have an x squared term. We don't have to include it. Then x minus 12. So this is now in standard form. And we can say g of x. Now the degree is what? 4. So whatever the biggest variable or exponent is, that's attached to the variable. Our type is quartic. And leading coefficient, almost, square root of 2. Questions on this so far? So let's look at C. Can we say this is a polynomial function? Why not? Negative exponent. apparently what's going to scroll. No, are not a polynomial function, or not a polynomial. So no, because we have a negative exponent.
For the homework, do you want us to write why it's not, or just leave it?
Just leave it. Okay, well, again, so let's look at the instructions and see what it said. Decide whether each function is a polynomial function. If so, write all this here. So it's not. So that's all I have to do. Why not? Because we can't have a variable in an exponent. So this is, no, as well, it's not a polynomial function. Questions on this here? I'm just putting a line for myself because to keep all of them separated, you don't have to do that because luckily y'all can write a lot smaller than I can on this board. So looking at the first one, can we say that 7 minus 1.6x squared minus 5x is a polynomial function? Yes, because it doesn't have negative exponents, fractional exponents, variables, and radicals. Two variables multiply together, so x squared doesn't count because we need two different variables. Variables at the bottom of a fraction or variable as an exponent. So this works. Is it in standard form? So how would we rewrite it? Five x plus, because we want, so the biggest exponent was 2, so we'll start off with x squared, then we'll have x if it's possible, and then our constant term. What's the degree? Because that's the biggest exponent. Our type is quadratic. Leading coefficient is negative 1.6, because the leading coefficient is always going to be the number in front of the variable with the biggest exponent. Once we get it in standard form, yes. Because if we grabbed it from the beginning, well, the first number was. If it's in standard form, it will be the first number. And if there's not a number specifically written there, it's understood to be 1. Let's look at number 2. Can we say this is a quadratic? Why not? Yeah, negative exponent, so no. How about number 3? Is it a quadratic? Or not a quadratic, sorry. It's not a quadratic. Is it a polynomial? Yeah. No negative exponents, fractional exponents. We go through the list. None of those show up. Is it in standard form? So how would we write it in the standard form? To the 4th, then the degree, 4, biggest exponent. Type, quartic, and lastly, leading coefficient. Questions on this here? You're good.
Thank you, Billy.
Questions on any of this here? We're ready for the next hardest thing. Evaluate. F of x equals 2x to the 4th minus 8x squared plus 5x minus 7 when x is 3. So what are we doing? Well, we're replacing x with So we're wanting to see what 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7 is. We're just plugging in 3 for x. And for any of these here, especially when we plug a number in for something, I would put parentheses around it if it's to a power, or just put parentheses around it to plug it in. Because, and this happens time and time again, if you have a negative number squared and don't put the parentheses, it will give you the wrong answer every single time. Because let's do, say, negative 3 squared. What is negative 3 squared? Negative 3 times negative 3. That's 9, yes? Because it should be positive 9, yes? Calculator's going to say it's negative 9. Because what the calculator sees is negative 3 squared. Negative 3 times 3. It doesn't see that as negative 3 squared. What it thinks you're wanting is this. It's going to square the 3 and then attach the negative to it. We want this, which is indeed 9. Putting those parentheses around it does make a difference. So, if we're looking at this here, there's 2 ways we can do it. One, we can do this by hand. Or we can plug it into the calculator. Either way works. Because 3 to the 4th is 81. 3 squared is 9. 5 times 3 is 15 minus 7. 2 times 81 is 162. 8 times 9 is 72 plus 8. 162 minus 72 is 90. And we get 98. That's 3 to the 4th power. We're saying 2 times 3 times 3 times 3 times 3. Now, what we could do, 4th. Well, try this again. 4 over. So when you use the exponent key, you do need to be careful that you actually get out of the exponent and don't type everything in the exponent, which I just did. And we get the same answer, yes? That's it. Any questions on this so far? Now, we've said, me and Miss Kendall and pretty much any math teacher you've ever had says do not use the variables on these calculators. They will give you the wrong answer. Do not use them to try to type them in. And there's a reason for it. Because if I just type X and hit enter, I get this here. I get a decimal. Now, what I can do is say 3 stow X and hit enter. Now, if I say X, it tells me it's 3. Because at this here, the calculator doesn't know what X is either. We have to tell it what X is at this point. So here we can say it's 3. Now, what's interesting with this is 2x to the 4th minus 8x squared plus 5x minus 7. X, and it'll plug that value in. Now, we could do this with any value. I could say -2, store X, and come back up here and select this again. And it'll do it. And this here, the nice thing with this is we don't have to worry about, say, -2 to the 4th, typing it in wrong. It understands that X is -2, and it's multiplied by itself 4 times. So, if we look at this next one here, We're going to plug 4 into this here. So we can use the calculator. So we could say -2 parentheses 4 to the 4th power plus 6 times 4 to the 3rd minus 3 times 4 plus 11. And we get the answer. Now the store feature is not just on the graphing calculators, it's on the 30XS. The other calculators do have it. Because whenever we do that, we'll type the number, store the variable. -2, well, we don't need the parentheses, x to the 4th plus 6x to the 3rd minus 3x plus 11. Give us the exact same thing. Number, stow, variable. And then just type the function in. Now, there's another way we could do it, because we're not looking at those. 2x to the 4th plus 6x to the 3rd minus 3x plus 11 is the function we're looking at, yes? I can graph it. We can say second graph. We're trying to see what's the value of, to evaluate it when x is 4, yes? Its value is -129. Because when we graph a function, we're plugging in those values of x and seeing what the outcome is. Questions on this here? Do we need to see another example of one of these? We're good with this here? Okay. The last thing we have is end behavior. Now, in behavior, there's 4 things that's going to happen, and really what we're talking about is the graph of a function. What is it going to do eventually? Now, we have 2 different types of functions. They're either going to be considered odd, the degree is going to be either odd, or the degree is even. So what we're saying is the biggest exponent attached to the variable is either going to be odd or even. It's got to be one or the other, because that's all we can have. There's only one number that is not odd or even, and that is 0. 0 is the only number that's not odd or even, but if we're talking about a function where the biggest exponent is 0, we're talking about a constant function and it's just a straight line. It's a flat line. It doesn't tell us anything. It's just that number. So the degree is the first thing that we look at within behavior. And the other thing we look at is leading coefficient. Well, there's 2 cases for leading coefficient. It's either going to be positive or negative. Positive or negative. And y'all have this already down on your note sheet, yes? Now, whenever we talk about in behavior of even, we'll look at even first, all the graphs end up making a U-shaped function. Because if we think of the quadratics, they were a U, yes? And they either opened up or they opened down. And no matter what the degree of the function is, if it's an end, or if it's an even, it's going to eventually, both sides are going to go up or both sides are going to go down, eventually. And that's really what this is showing. This little dotted line in the center, you don't have to circle it, is saying that there's going to be stuff going on in the center. It's either going to be going up, down. It's kind of a wave function. or look like a wave, but eventually both sides are going to end up going up or both sides are going to end up going down. There's going to be one of the two. And really, it's going to tell us if the degree is even and positive, eventually both sides of the function will go up. So what we say is that as f of x, as the y values approach infinity, x is going to infinity. F of x approaches positive infinity, and so we'll say plus infinity, as x approaches positive infinity. And f of x will approach positive infinity as x approaches negative infinity. And really all that's saying, so x, the values we're plugging into it. As I plug bigger values of x into the function, this graph, as we go this way, will go up. It'll eventually go up at a certain point. It'll start going up. Now, as x approaches negative infinity, as I plug in smaller and smaller values of x, the function is going up, because eventually they're going to both go up at some point. And if it's negative, that means it's going to go down. So that means the y values, f of x, approaches negative infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. If we're talking about even degrees, they're both, f of x is going to go in the same direction. They're either both going to go up or they're both going to go down. Now for odd degrees, they go in opposite directions. For odd and positive, f of x approaches positive infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. And with the negative leading coefficient, it flips it. So f of x approaches positive infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. Okay, let's go on and look at the first example of this here. So describing in behavior. What is the degree of this function here? 4, which is even. Leading coefficient is negative 0.5, so this is negative, yes? So looking at that chart that we have, I need to go to even degree, negative, yes? So that means the end behavior is going to go in the same direction. So we're going to say f of x approaches, make sure, yep, we're using arrows. F of x approaches positive infinity as x approaches positive infinity. That's kind of just what it's saying. It's saying as x is getting bigger, we plug bigger x values into this function, the y values will get bigger. And f of x approaches, sorry, I'm losing my mind. So it was negative, not positive, yes? So should it be going up or down? Should be down, which is one slight change, because both of these would be negative. Because if the leading coefficient's negative, f of x approaches negative infinity as x approaches positive infinity, and f of x approaches negative infinity as x approaches negative infinity. That's it. That's really all this is. That's the answer. Bless you. Questions on this here? Yeah. Because if we look at this graph, we can see that the two ends do shoot down and they continue to go down. So f of x approaches negative infinity as we go to the right, and it went to negative infinity as we went to the left. That's all this is saying. So let's look at this next one. What's the degree? Which is, and the leading coefficient is negative 0.3, yes? Which is our negative. So f of x approaches infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. Odd negative. Because what we'll get is some function that's going to do something like this eventually. It won't look exactly like that, but eventually we're going to have the signs going in that direction. So that's all we need. Questions on this here? But if it is odd, we know that this first part, f of x approaches, the signs for those two infinities are going to be different. If it's even, those signs are going to be the same. Let's look at the next one. We good to look at the next one? So the degree, is it odd or even? Odd, because the degree is 3. Leading coefficient, is it positive or negative? Positive, yes, because the number in front of x to the third, the biggest exponent, is positive, yes? So f of x approaches positive infinity, and we'll have f of x approaches negative infinity. Because it's odd, we know that f of x is going to approach positive infinity and f of x is going to approach negative infinity. They're going to go in two different directions. Now, since it's positive, f of x is going to approach positive infinity as x approaches positive infinity. And f of x will approach negative infinity as x approaches negative infinity. Questions on this here? Now, the reason that this is helpful is it's going to give us an understanding of how the functions will work, how the graphs look. Because if I know that it's an odd function, the end behavior should go in opposite directions, yes? So if I'm given a function like this is what the graph shows, and I know it's odd and positive. Well, we know what? The function should go in opposite directions, yes? Which means at some point, because again, this is where the window ends, this function should come back up. It gives us an idea of where the zero should be, or kind of what the graph is going to do. And that's the main thing with this here. And that's the end of 4.1.